Okay, finishing up our discussion on vector addition by components, we have number 6 on the worksheet. A ship sets sails for its island destination located 1,250 miles at a bearing of 49 degrees south of east from its point of departure. The ship begins by sailing for 315 miles at 11 degrees east of south at a speed of 20 knots or 23 miles per hour. It then turns so that it is headed at a bearing of 32 degrees south of east and continues sailing at an average speed of 24 knots, 27.6 miles per hour, for 1,020 miles. How much farther must the ship travel and in what direction to arrive at its destination? Hint, 1,250 miles is the resultant. Okay, so we're going to start off with this 1,250 miles is the resultant. That's the original thing. So we're told that the island destination is right here with respect to its original point of departure. So since it's heading at a bearing of 49 degrees south of east, so we're going to be traveling southeast. So we're going to start in this upper left corner over here to give us plenty of space on the graph. 49 degrees south of east. So with respect to east, we're heading 49 degrees south of east, so that's a little over halfway between that and the vertical. So we're going to say 49 degrees south of east. Our island's going to be somewhere down here. Okay, and that's 1,250 miles, 1,250 miles, and that was also the resultant. So I'm going to go ahead and fill this in now. 1,250 miles is the resultant. Okay, so this is going to give me my total. Okay, so my total distance or my total displacement is this and this. Okay, so we have our dx total and our dy total. Okay. So when we go to figure that out, that's going to be what we're going to put over here. All right, so the first leg of the journey, I'm going to go ahead and do in red here. So it says that the ship begins by sailing for 315 miles at 11 degrees east of south. So now it's heading a lot more south than it is east. So 315 miles, so about a quarter of the distance total. So I'll make my thing as close to scale as possible. 315 miles east of south. So it's a very narrow angle here. East of south, okay, for a total of 315 miles. So that is going to be 315 miles. And then it has, of course, two components. It has the southern component here, and it has the eastern component here. So this is going to be my dy1, so that's my distance in the y direction for the first leg. And then down here is my distance in the x direction for the first leg. Okay, I'm also going to go back and label some of my angles. So my original angle for the resultant was 49 degrees south of east. For my first leg of the journey, that angle is 11 degrees east of south. So that's my 11 degrees, my really narrow angle right there. So now in order to figure out these two components, the dy and the dx, I'm going to need to use my trig functions just like we've been doing. With respect to my 11-degree angle, dy is the adjacent side because it's next to it. Dx is the opposite side. So in order to figure out my dy1, I'm going to use adjacent over hypotenuse, which means I need to use cosine. So cosine of 11 degrees is equal to my dy1 that I'm looking for over 315 miles. Okay, for the dx1, because it's the opposite side, Okay, the opposite side for dx1, opposite over hypotenuse is the ratio for sine, so sine of 11 degrees is equal to dx1 over 315. Okay, so that's how I'm going to find dx1 and dy1. On the next leg of the journey, so now starting from where we left off, the next leg of the journey, it then turns, so it is headed at a bearing of 32 degrees south of east. So I'm now heading back towards the island, but I'm heading only at 32 degrees. So here's my eastern sort of bearing, and then my southern bearing is going to be going this way. So let's see what we need to do. 32 degrees south of east and continue sailing at an average speed of 24 knots for 1,020 miles. So 1,020 miles. Well, I've already gone 315 miles, so 1,020 miles, that's quite a big chunk. It looks like we're probably going to overshoot. So I'm going to go ahead and draw what I think is closest to about that. And it was at 32 degrees. Okay, so 32 degrees. So our two components now, of course, we've got the eastern component, and then I'll redraw my southern component over here so that I can make my angle with respect to the bearing that I was given. Okay, so this is going to be my distance in the x direction for the second leg, so dx2, and my distance in the y direction for the second leg, because that's my south direction, my east direction. Okay, so dx2 is the direction in the east, dy2 is the direction in the south, or the distance to the south. Okay, with respect to 32 degrees, dx2 is my adjacent side, dy2 is my opposite side. Okay, and my hypotenuse we were given as 1,020 miles. Okay, so 1,020 miles is my hypotenuse. Okay, so again, using my trig functions, for my dx2, I'm going to use adjacent over hypotenuse, which means I need cosine. So I'm going to use the cosine of 32 degrees is equal to dx2 over 1,020, and then solve for that. dy2, since that's opposite over hypotenuse, that's going to be sine of 32 degrees is equal to dy2 over the hypotenuse, which is 1,020 miles. Okay, so that's what I'll fill in once I solve for those. That's what I'll fill in over here for dx2 and dy2. And then the final leg of my journey is what I'm really looking for in A. How much further must the ship travel and in what direction to arrive at its destination? So the last thing that I'm going to do is go from where I left off, and I'm going to go directly to my end point there. So all I need to do is figure out what that resultant vector is. I can tell what direction is because I know that I've overshot here. So I'm now going to head at a bearing of, it looks like southwest. So I still need a little bit further to go south, but I now need to turn and go west. So southwest is going to be my final direction. How much further I have to go? Well, in order to figure that out, remember we're doing it by components, so all I need to do to find this out is to take my dy total, okay, and subtract, take away, the dy1 and dy2, and that will give me dy3, because remember that dy1 plus dy2 plus dy3 equals my dy total. So if I'm working backwards, I've already calculated or can calculate my dy total, and then I do the same thing with the x's. dx1 plus dx2 plus dx3 gives me the dx total. I'm looking for dx3. I will have already found out dx1, dx2, and dx total, and then same thing over here for the dy's. Okay? So then, once you do that, figure out your x direction and your y direction, and then that will help you figure out what the total time is that it will take, because it's saying that it says how long will the trip take if the ship travels at a speed of 18 knots or 20.7 miles per hour during the last leg of the trip. Well, remember the last leg of the trip was that little leg right here. So you have to take your dx3 and dy3, use the Pythagorean theorem to calculate that last leg, because we're not going down and then over, we're going in a straight line. So dx3 squared plus dy3 squared is equal to that last leg, and we'll call that dr3, because it's the resultant vector, but it's of the third leg, so dr3 squared. So that gives us the last leg. Okay, once we figure that out, and then all we have to do is, if that's our distance and we're given 20.7 miles per hour, we'll find a value for our miles right here. So then we would take to figure out what that time is. The time would be equal to the total distance that we've traveled, that dr3, divided by 20.7. And that will give us our time in hours that the last part of it took. And then we'd have to go back and look at the other two parts. So for the first leg, it's 315 miles at 23 miles per hour. So 315 miles. So my time 1 is 315 miles divided by, and then what was it again? 23 miles per hour. Okay. My time 2 is, let's see, where did it go? 1,020 miles at 27.6 miles per hour. So 1,020 miles. 1,020 miles at 27.6 miles per hour. And then my T3 is what I will calculate here. So then once I add all three of those together, that will give me the total time for the trip.